Welcome. My name is Irvin M. Howard. I am the EMH Math Portal online tutor. Welcome again to another EMH Math Portal college algebra instructional videos. From our last video, we talked about negative exponents, and I want to continue our discussion on negative exponents, but we're going to solve negative exponential expressions. And to solve negative exponential expression is to simplify each expression and write the answer without negative exponents. Now, from our last video, you recognize that when you will see a negative exponent or a base that has a raised negative integer exponent, there's a certain procedure we have to follow using the formula of negative exponent rule. And just to remind you of what the formula is, you probably remember, I'll just write it down here. The negative exponent rule, and that rule represents by the formula a raised to the power of m equals to 1 over a raised to the power of m. And notice that when I write it, the raised negative exponent, this becomes the inverse or reciprocal. All right, you take the reciprocal of this, 1 over a raised to the power m. Now, not always that it will look like this, because there may be chances where you may have a negative already in the denominator. And that's part of the reason that I want to go over these circumstances with you on this video, because not all the time that you'll have a negative exponent located in the numerator, it could also be in the denominator as well. All right, I want to give you several examples, such a case, maybe one or two, but I'll give you the first example. Let's look at the first problem. We're going to have 3x z square. All right, I like to write my z's with a slash just to distinguish from the z and a 2, divide over y raised to the power of -4. And here we have the raised power, negative raised power, or the negative exponent in the denominator. All right, so we could write it like that, but I want to show you the same application of using another strategy which exemplifies the same thing. All right, but let me show you the application of the formula first, and then I'll show you the other strategy. Now, like using the formula, you're going to take this and render it into its raised power by writing the formula for that is negative exponent becomes positive by using this formula. So we're going to write everything the same, except we're going to make the change. We have 3x z square over. Now we're going to take this right here and apply it with the formula. So that would be 1 over y to the 4th. All right. And like always, you see that these represents a division of rational exponents. And what you would do is, it's the same thing like when you're dividing. It's the same thing like when you're dividing 3x z square divided by 1 over y to the 4th. All right. So when you have that, you know what happens. This becomes the reciprocal again because you're dividing. So this symbol right here takes the place of this. All right, division sign. So this equals to 3x z square, and then we multiply by the reciprocal, which would be y to the 4th, and it inverts. Okay, this is invert, excuse me. All right, and then this equals to, all right, I'm gonna write it down here, 3x y to the 4th z square. All right, okay, all right, I hope you all seen that example. Now this is to apply the formula. All right, when we apply the formula. Now I want to show you the same method, but instead of writing it as the formula, now that you practice with using the formula, I want to practice using a shortcut, which will be the same situation. I'm just going to write this line, draw this line on here so that we can separate it, so that you can see the difference. And I'm going to write the same problem here. Okay, all right, let me just, all right. Okay, we're going to have the same problem, 3x z squared over y to the negative 4, all right? All right, now that we have the understanding of using the negative exponent and the rule, notice that when we write it, we can take the shortcut of dividing, of multiplying by the reciprocal. When we have this problem in this circumstance, in this situation, if we apply the same approach, it'll be the same. But if we recognize that in the denominator, this is the denominator, all right? If we have raised powers in the denominator, we can flip them. All right, we can flip this because it will be the same thing like when we're multiplying by the reciprocal. So when we have negative exponents in the denominator, all we have to do is raise it, but we'll still have the negative exponent rule apply. So all we have to do is invert it by moving it to the denominator. So this equals to 3x y to the 4 z squared. Right. So all we have to do is when we have negative exponents in the denominator, the negative exponent will become positive when we take the base and the negative exponent to the numerator, and it becomes positive. So we just the sign will become positive. Now, if we have certain other situations where we have a raised negative, just like the formula, then it becomes positive in the denominator. But in this case, we made this from the denominator and we changed the sign so that we invert it to the numerator. Okay, I hope that's clear. All right, you can continue to look at that problem and just practice on it, and we'll look at another problem. All right, I'm going to give you another problem. We'll give you an example of a problem that has no fractions in it, and we'll show you how it becomes inverted. We're going to have this 4 raised to negative 2, and we have x raised to negative 1, okay? And then we have y squared. Now, in applying the formula, all right, in applying the formula, just look at the negative exponent with the base, all right? Again, you can do numbers the same way, all right? So we're going to apply the formula, all right? So this, using the formula, this becomes 1 over 4 squared, okay? And this becomes 1 over x. And notice it becomes positive. Now, if there's not a number for the raised exponent of the exponent, it's understood to be 1. They have the negative so that you can see that the signs are negative. And also, if you don't see a sign next to the negative, if you don't see a signed symbol next to the exponent that's understood to be 1, then it should always be understood to be positive. All right. Okay, and then we just combine them together. I'm just trying to give you a show you a difference in this. So we have 1 over 4 raised to power 2, okay, and times 1 over x. And notice that y to the second power is still positive. So that still stays the same. It's only when you have a negative exponent that you apply the formula. So there's no reason to apply the formula because it stays at its original position. And notice that y squared is considered a whole value, so it stays the same. So the only thing that happens is that these values become applied to the formula. They become values in the denominator. All right, so you'll have y squared over 4 squared x. All right, okay, and then let you see that. And then this equals to y squared All right, and then you have to, that is a little too big. Make it look like a 42. All right. Then you have y squared, and then simplify this. All right, 4 squared would be 16x. All right, and that's your answer. All right. Okay. Let's try one more, and what I'll do, I'm going to take this paper and just turn it on the back. I don't have my my header for math tutor, but that's okay. Let's try another one. We're going to have negative 3 raised to the power of 3. We have x squared, and then we have y raised to negative 3. All right, and just zoom it in. All right. Okay, now look at each instance. All right. And I probably would think that you probably would already know that automatically. You would think and assume that you would apply the formula, but we can't apply the formula to values that have a negative base. All right, we only apply the formula if the what? The exponent is a negative value. All right, so we can see here that this and this, they don't look the same. All right, we only apply the formula if the exponent is negative. All right, in this case we don't, so we leave this alone. We leave this alone because this is not what? Negative, all right, because it doesn't apply to the formula. But we see here that y raised to the power of negative 3 is a negative. The exponent is negative, so we apply the formula for this one. So we'll write the other parts of the expression as the same. But we're going to what? Change this to apply the formula because you have a negative exponent. So you have y over 1 over y to the third. And notice the sign will change. All right? The sign will change. So this equals to, so if we multiply this times itself, you have your negative 3 times, which is a negative 27 x squared, and since this is 1 over y to the third, all right, so we simplify this as negative 27 x squared, and since y to the third is in the denominator, then it goes to the denominator. All right, so you'll have negative 27 x squared y over y to the third. All right. If you have any questions, I'm still trying to put my math blog up there. If you can be patient, I'm just trying to get everything together, and you can save your questions and I'll try to answer them as soon as I can. But again, practice makes perfect. Try to memorize each of the formulas that you view the videos, all right, because when we get to the last video, it will combine all of these properties into one or several exponential expressions that we have to apply the properties to solve a exponential problem. So take the challenge, and I'll see you again. This is Irvin M. Howard as the EMH Math Portal online math tutor, and you have a good day. And I like to say again, life is worth living.